By the time you finish watching this video, you will be learning concepts like supervised learning, unsupervised learning, reinforcement learning, regression, classification, and so much more. And the topics that we'll be discussing it not just in the brief, rather we'll be talking in depth so that it will be very, very helpful going forward. So without wasting any more time, let's jump into the screen. Let's talk about machine learning first. And let's talk about why the machine learning came into the first place. So before machine learning, there was general programming in which, let's say, we are going to do a email classification problem in which, let's say, an email contains the word free. It has number of links 14 and capital letters in that email are 85%. Then it is going to be categorized as spam. So in general programming, if you're targeting for the word free, it's going to definitely catch the word free. But by any chance, if the word became freely, our general programming will miss it, because general programming is basically hard coded. Anything related to free or something like that, if it is not exactly matched, then it's going to bypass it. For example, free and freely, and free also, if we have done free like this and the word came like free in capital letters, and if it is not written properly, there is also a chance you're going to bypass it. But what machine learning does is, one machine learning learns the word free and similar kind of word, it learns the underlying pattern of the data. So once it is trained, it is also going to take freely or absolutely free into consideration. When the email comes, this box contains free will be yes. So that is the benefit of machine learning. It learns the underlying pattern of the data so that you don't have to hard code things again and again. Now here we have taken an example of email classification. So as we have already discussed, this is called features, which is input, and these are called labels, which is output. This is also called independent variables, and this is called dependent variables, as this is dependent on this. So based on the features and labels, machine learning can be categorized into three parts. One is supervised learning, one is unsupervised learning, and one is reinforcement learning. Now let's talk about supervised learning. What happens in supervised learning is, we provide both features and labels to train the model, and once the model is been trained, we just give the features and we wait for the result is what we expect the results, what the model is predicting. According to that, we test the accuracy of the model. So supervised learning में you have to give both features and labels. After the training is been on the training phase, after the training is been done, you have to give only features to see what labels it is predicting. Now supervised learning can be classified into two parts. One is classification and other one is regression. Now what classification does is, it classifies, let's say we have a binary classification which has two outputs, 1 or 0. It can be, let's say, spam, or it can be, let's say, not spam. Now this can also be not just two outputs, it can be three outputs. Let's say we are going through a sentiment analysis. This can be positive, neutral, or negative. So in that case also, we can use classification problem, that is called multinomial problem. Multinomial problem. On regression, what happens, the output are not fixed. Here if you see on classification, output are fixed. Either it will be spam or it will be not spam. Either it will be positive, neutral, or negative. So output are fixed, but in regression output won't be fixed. For example, housing price. So what happens in housing prices, let's say, where entering the size and price. So with the increase of size, obviously the price is also going to increase, right? So this cannot be fixed. Bigger the size, bigger the price, smaller the size, smaller the price. So output here is not fixed, but because this is coming under supervised learning, we have to train the model first with both feature and labels, then we provide only features to see the output. Now there are popular models in classification problem, and one of the popular model is logistic regression. The name has regression, but this is a classification problem, please remember. Now let's understand logistic regression using this email classification model. Now when we give these inputs to the model, these inputs contain something called weights. Now weight is, for now you can understand nothing but the importance of that input. So for the email classification model, this contents free will have, if it is yes, will have much more importance, which is much more weight. Now number of links also will have more importance, but less than contents free. And all caps, if the capital letters in that email are 85%, it will also have some weight, but it will be lesser than contents free and number of links. Because models are just mathematical formulas, they cannot process direct word free or number of links or so like that. So because of that reason, we have categorized things into mathematical numbers, which is weights. So let's say for the first line, the word contains the weight, let's say 2.8. Now number of links, let's say it contained 1.2. Now all caps, let's say it contains 0.5. Now if you're going to calculate, this is going to be 4.5. This 4.5 will be passed through an activation function. Now in logistic regression, we use an activation function called sigmoid. Now if you see the sigmoid function, what it does, it can take any number between plus infinity to minus infinity, and it can create a result between 0 to 1. So any number you take plus infinity to minus infinity, it is going to put in this curve, which is 0 to 1. So let's say we passed 4.5 into sigmoid function. Let's say the result came as 0.8. Now because we will have 0 and 1 output, let's say we'll be doing, if the output is 0.5 greater than 0.5, that will be 1. If is less than equal to 0.5 is equal to 0. So greater than 0.5 is 1, is a spam, and less than equal to 0.5 is a not spam. So if you pass 4.5 into the sigmoid function, let's say it brought 0.67. So 0.67, if you see, is greater than 0.5, right? So the output will be inclined towards 1. Okay, and that is how it's going to create the result as spam. Similarly, if we go for this, here is, if you see contents free, it is a no. So the weight will be very, very less. So let's say it is going to come 1.05. Now number of links also 2. Let's say that is also going to come very, very less weight. So let's say it came 0.7, and all caps also 5%. So that is going to come 0.0503, let's say. So if you calculate, the total will be 1.78. Now this 1.78 will be passed through an activation function, which is sigmoid here, and that is going to give, let's say, a result. Let's say it's going to come 0.06. Now 0.06 obviously less than 0.5, which will be resulting as 0, and that is going to be not spam. Please remember, these are not actual figures, this is just for the understanding purpose. Now next we have is decision tree classification model, in which this works with a lot of yes no question. So let's say it's going to ask, the first question is, does it contain the word free? If it is contain the word free, then it is going to go in this direction. If it doesn't contain free, this is going to go in this direction. So if it has free, it is going to ask number of links in that. Number of links, if number of links are high, let's say greater than 5, it's going to continue in this direction. If it's less than 5, it is going to continue in the next direction. Let's say if it is greater than 5, it is going to classify as spam. If it is less than 5, it is going to classify as not spam. Now here if you see, if the email doesn't contain free, then it's going to check whether the mail has come from the known or unknown contact. Known or unknown contact. So if it is from known contact, it is going to go in this direction. If it is an unknown contact, if it is going to go this direction. Let's say if it is from known contact, it is going to categorize as not spam, because you know the person. Now if it is from a not known contact, it is going to categorize as spam. So it's a lot of yes no question that happens, and it flows in this direction. Now, one more popular model we have is random forest. Now, what happens in random forest is it's a combination of multiple decision tree models. Easy to remember is, this is tree, this is forest. So, multiple trees are become forest. So, how does this work is, so we give different test data. Let's say this is a result set 1. This is going to be passed with a decision tree 1, and this gave a result, let's say spam. Now we have a result set 2, and this passed to a decision tree 2, and result came not spam. Similarly, one more result set we have, and this goes to a decision tree 3, and this came as a result spam. Now the total, if you see, there are 2 spam and 1 not spam. So obviously the result is going to be spam. So that is how random forest works. There are other models also, but these are popular models. If you go to the Gemini, there are support vector machine, there is k nearest neighbors, there is naive bias. But the thing is, if you're going to discuss everything, this will be overwhelmed, and if you think this is going to be very difficult, you're going to lose it. So let's understand easily first, then if you think like if you want to go deeper, at least you'll be knowing the terms and you can go deeper. Now to check the accuracy of the supervised learning, we have a concept called confusion matrix. Now what happens in confusion matrix is, here we have taken a y-axis and x-axis graph. In y-axis, we're going to see the actual result, and this is going to represent the predicted result. You know, while testing, this is when you process the data, you know this data supposed to be spam and this data supposed to be not spam, right? But when you pass the model, there can be two options, right? This can go exactly as you expected, which can go spam, or it can go opposite, which it will go not spam. Now when you pass this, let's say for this, we expected spam, sorry, we know it is going to be spam, and the predicted result is also spam. So both the things happen as our desired, so it is going to be true and positive. So here we'll be writing true positive. Now in this case, what happens, expected is spam, but this came as not spam. So what happens, this is what we expected, it came ulta of that, right? So this is going to be false negative, because not spam came, we're going to go false negative. Now similarly here, what happens, we expected not spam, but the result came spam. So what happens here? The result is reverse to our expectation. So this will be false, and for the spam we're going to write positive. Now here we expected not spam, and the model also gave not spam, so which is true negative, because the result came negative, right? Watch this again and again, you'll understand better. So what happens here, if you see, there are two true positive, true negative, and two false positive and false negative. So the result, the accuracy percentage will be calculated as total true positive plus true negative by total set of results, which is 4 into 100. So let's say we have taken 20 records, and from that 20 records, 12 records are true positive and negative, rest are false positive and false negative, like that. So total is 12 divided by 20 into 100. So the output will be 60% accuracy. Now once you get 60% accuracy, if this is not enough, then you're going to retrain, or you're going to take measures to increase the accuracy of the model. Understood? Now I think video has been long, so I'm going to take a pause here. Next episode will be other part of the machine learning. To make this kind of video, it takes a lot of effort, so I would highly request if you can subscribe and share this video with your fellow friends.